Uh, Hello everyone, I'm Yichi Zhang from Zhejiang University, and I'm very glad to present our work about knowledge graph compilation in the SIGIR conference. Though we cannot attend the conference in person, we still try to present our paper with the Zoom-based presentation, and we are very thankful to our proxy presenter, Jinting Wang. She greatly contributes to the presentation of our paper. So let's begin our presentation now. The title of our paper is NativE, Multi-modal Knowledge Graph Compilation in the Wild. So let's start by some basic research background. So knowledge graphs consists of factual triples in the form of head entity, relation, and tail entity. They store the word knowledge with the triple form. Besides, multimodal knowledge graphs further extends the knowledge graphs with multimodal content such as images and texts to improve the representability of the knowledge graphs. They are the large-scale semantic networks that are useful in many artificial intelligence tasks. Knowledge graph compilation and multimodal knowledge graph compilation is a task which aims to predict the missing links in the given knowledge graphs while considering the multimodal information of the entities. This task is motivated by the completeness of the multimodal knowledge graphs because there are many missing triples in a given knowledge graph. So, multimodal knowledge graph compilation aims to mining the missing triples with collaboratively modeling the triple structure in the knowledge graphs and the multimodal content of the entities. However, according to our observation, there are several problems in the existing multimodal knowledge graphs. We conclude them into two different perspectives. The first is the diversity problem in multimodal knowledge graphs, and the second is the imbalance problem in multimodal knowledge graphs. The diversity problem in multimodal knowledge graphs means that there are more and more kinds of multimodal information are included in the newly constructed knowledge graphs, such as numerical values, audio, and video. However, existing multimodal knowledge graph compilation methods usually considers only the visual and the textual information. The newly added multimodal information are not considered and included in the design of the existing methods. The imbalance problem means the distribution of the multimodal information among entities is not balanced. Some entities may have a lot of multimodal information, while some of the entities may have no multimodal information at all. So these two problems limits the generalization of the existing multimodal knowledge graph compilation methods and need to be improved. Therefore, we propose a new framework called NativE to embed the numeric, audio, text, image, and video information in a unified representation space and to achieve the multimodal knowledge graph compilation task. So let me introduce the detail of our method next. Here is an overview of our method. We present two new modules in our new framework. The first module is the relation-guided dual adaptive fusion module, and the second module is the collaborative modality adversary training module. These two new modules serves different roles to achieve a better performance when facing the imbalance and the diversity problem of the multimodal knowledge graph completion tasks. We first introduce a multimodal encoding process which can encode the multimodal information from the entities as an initial feature. For example, we can encode the images of the entities with a VGG and encode the textual descriptions of the entities with BERT. Finally, we will get an embedding or representation vector for each modality of each entity and learn a multimodal knowledge graph completion model in the next. We then design a new model called relation-guided dual adaptive fusion model. This model can get the joint embedding of each entity. We designed a relation-wise temperature and adaptive weights for each of the modality in an entity, and we measure the triple plausibility with a rotate E score function. This function projects the entity and the relation embeddings into the complex space and use a complex addition to model the triple plausibility. The training objective of our multimodal knowledge graph completion model is to give the positive triples which are correct with higher scores and give the negative triples which are not correct or incorrect lower scores. Therefore, we use a contrastive-based training objective to train our multimodal knowledge graph completion model. This is a basic setting of the multimodal knowledge graph completion models. We then design a collaborative modality adversary training model to enhance the imbalanced and missing entity informations for each modality. This model is designed with the WGAN framework, which plays a min-max game between the discriminator D and the generator G. In our design, the generator aims to complete or enhance the raw modality features with a newly generated embeddings. We can construct synthetic embeddings and synthetic entities with the help of the generator. Besides, in the multimodal knowledge graph completion model, we can find that the score function we designed before is a discriminator which can discriminate the triple plausibility with a scalar score. So, in our design, the discriminator of the WGAN framework is the multimodal knowledge graph completion model itself. We play a min-max game between the generator, which is a two-layer MLP, and the KGC model, which is implemented by the entity embeddings. We also give a theoretical analysis to show why such a design would work through some simple theoretical analysis, and the further derivation can be found in the paper. If you are interested in this derivation, you can refer to our paper to know more about it.